Hey everybody, we are on to law of sines today. Let's get started. So one of the things that we need to remember is what an oblique triangle is, and it's a triangle that has no right angles. And what the law of sines says, that if we have this triangle where this is angle A, angle B, and angle C, side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. And it says that side A divided by the sine of angle A is equal to side B over the sine of angle B is equal to side C divided by the sine of angle C. If triangle ABC is a triangle with sides A, B, and C. So to solve an oblique triangle, you need to know the measure of at least one side and any two other parts. So it could be sides or angles. So when we can use the law of sines when we are given either a triangle that has two angles at a non-included side, also known as the angle-angle side case. We can use another triangle with two given angles and the included side, the angle side angle. Or the third case is two sides and a non-included angle called the side-side angle. The trick is, as long as you have one side and an opposite angle, okay? So for example, for the triangle shown, at the right angle A is 31.6, so that's right here, 31.6 degrees. Angle C is 42.9 degrees. And side A, we know side A is across from angle A is 10.4 meters, which they gave us here. Find the length of side C. Well, we know side C is across from angle C. This is what we're looking for. So because we have the opposite angle and its side and this opposite angle, and we're looking for this side, we can use law of sines. And law of sines says that we can use the we can use side 10.4 divided by the sine of its opposite angle equals side C, we don't know it, divided by the sine of its opposite angle, 42.9. Now we're going to use cross multiplication to multiply this. So now we're left with 10.4 times the sine of 42.9. Oh, and I'll kind of run out of room here. Equals C times the sine of angle A, which is 31.6. So if I want to get, I'm going to cross this out for a second so you guys can see it. So if I want to get C by itself, right here, we're going to divide both sides by the sine of 31.6 degrees. And we're left with C equals all of this. We're going to put this in our calculator first, 10.4 parentheses sine 42.9. Make sure that you end your parentheses. All divided by sine of 31.6 and parentheses. And we get approximately 13.5 meters. Okay, so what about this case? If there are two sides and one opposite angle of an oblique triangle, so if you've got this triangle, we've got two sides and one opposite angle, so we can call it like this, then there are three possible solutions or possible situations, which are, one, there could be no such triangle exists. Two, one such triangle can exist, or 3, 2 triangles can exist. There's 3 possible situations. So, for example, if you've got a triangle and it says, well, we've got this triangle, we'll just label it A, B, and C because we need to be able to label it. And it says angle A is 25 degrees, side B is 54 feet, and side A is 26 feet. How many solutions are possible? Well, here's the thing. We don't know this angle, but here's what we know. So we know we can say, well, I've got this angle and this opposite side. So we can say the sine of 25 divided by its angle, or its opposite side, equals this side, but we don't know angle B. So we can say the sine of angle B over 54. Let's cross multiply. So we end up with 54 times sine 25 equals 26 times the sine of B. We're going to get 26 off of both sides, divide it, and we've got sine B equals all of this, which is approximately, so when we put that into our calculator, what do we get there? We get 54 sine 25 all divided by 26. Let me get my calculator. We get 0.877. In order to get sine off of the angle, we're going to take the inverse sine on both sides. So here's the thing. This inverse of sine B, we're going to take that, we're going to go inverse, so you hit shift or second of the value 0.8777, and I get approximately 61.37 degrees. Now remember, sine is a positive angle here, so this could be 61.37 degrees. But remember, sine can also be positive here in the second quadrant. So what would a 61.37 degree angle be here? Well, we're going to do 180 minus, so up to here, and we get 118.63 degrees. So we have 2 options. It could be 118 or 61.37. So we know for sure if I plug this in here, that's not going to be a problem. But we also have to make sure that 118 degrees is going to work. So for here, there's 2 possible solutions. Okay. We're going to go ahead and do this one in class. Okay. Let's do, but it's the same process, but we're going to do that one in class. So the area of an oblique triangle is 1/2 the product of the lengths of 2 sides times the sine of their included angle. So that means the area is 1/2 times the 2 sides times the sine of the included angle, or it could be 1/2 side A times side B times the sine of side angle C, or it could be 1/2 A times C times the sine of angle B. So for example, find the area of a triangle. So let's draw it. A, B, and C. Of the 2 lengths, 30 feet and 48 feet. So we'll just say this is 30, we'll say this is 48. And the included angle, so included angle would be right here, is 40 degrees. Okay, so let's find the area. So we're going to take area equals 1/2 of the two sides multiplied and the sine of its included angle, which is 40 degrees. And what's cool about this is you can just plug it straight in to your calculator. We get 462.8 feet squared. Okay, that's it for today. Thanks.